Right, back to business. Graphs of other trigonometric functions. The last thing we did before the exam was graphing sine and cosine and transformations of sine and cosine functions. Remember, we have 6 trig functions, not only 2, so there are 4 left. And we will quickly go over, not in detail, a little bit faster, those 4 graphs. Graphs of cosecant, which is on the left, graph of secant, which is on the right, 2 more coming up in the next pages, tangent left and cotangent right, and we will have 4 questions about them. Okay, so the idea is very similar to sine and cosine. You need to know the initial main graph, and then according to the numbers present in the trig function, they are going to start stretching or shifting right or left, and period changes can happen as well. So we are going to compute those just like in the previous section. So the first graph we are going to take a look at and analyze is cosecant. Cosecant. Again, all trig functions are periodic. It keeps repeating one frame. One basic picture keeps copies over and over to the right and left. And this is the part, it's always being copied. One U shape, one upside down U shape. This frame between these 2 dashed lines, they are called vertical asymptotes. There are 2 vertical asymptotes again, minus pi and pi. Those asymptotes and everything in between keeps repeating. Paste, copy, paste to the right and left. So when you continue, you're going to have these all over the place. Okay? U upside down U, U upside down U. So all you need to keep in mind is these 2 shapes, parabolic shapes. They are called, look like a parabola. There are some significant points, such as again the left side asymptote is at minus pi, the right side asymptote is pi, and you're getting close towards those asymptotes on that far ends. And in the middle, there is another asymptote actually right here in the center. It's actually x equals x equals 0, y axis, and looks like I need to rerun this. Alright, we're back on. Sorry about that. And again, we were talking about significant values. There are 3 asymptotes, minus pi, 0, and pi. And there are 2 U-shapes. One is going up to the left and right of point pi over 2 and 1, this red point. The other one is going down, starting from this red point, minus pi over 2 and 1. What I see here is between this zone, look, between 1 and minus 1, you pretty much have nothing. So your curves or your shapes never fall in between these 2 values. So values of cosecant is always more than 1, like 2, 3, 4, or it's less than negative 1, negative 2, negative 3, all the way into infinity. Very similar idea for secant. It's always the values are beyond 1 and negative 1. You're lower than negative 1 values or more than 1, nothing in between. And the shape is identical to cosecant, only there is a delay or there is a shift. You pretty much shift this U shape to the center of y-axis. Right, this. You move everything pi over 2 left. You see, there are 2 asymptotes. Again, 3 asymptotes. However, this time the asymptote, this shape is pretty much repeated, so I'm looking at this frame. The left side asymptote is minus pi over 2, the right side is 3 pi over 2, and the center asymptote is at pi over 2. So this shape is repeated over and over. Every odd multiple of pi over 2, like 5 pi over 2, 7 pi over 2, negative 1 pi over 2, negative 3, negative 5 pi over 2, every odd multiple of pi over 2, you have an asymptote for secant. For cosecant, you have an asymptote for every multiple of pi, like negative 1, negative 2, negative 3 pi, all asymptotes. Pi, 0, pi, 2 pi, 3 pi, all asymptotes. Okay? So these are the significant things summarized here as well. I mentioned them over the picture, but they are all summarized. Again, both functions have 2 pi period. Every 2 pi, it keeps repeating itself. It has vertical asymptotes. Cosecant has at every multiple of pi, like 0 pi, 1 pi, 2 pi. But secant is at pi over 2, 3 pi over 2, 5 pi over 2. Again, these are pi over 2, 3 pi over 2, 5 pi over 2. Negative or positives, both sides. Plus, minus, plus, minus, plus, minus. Okay? And range is again beyond negative 1 and positive 1. I said that already. Did I miss anything? Yeah, symmetry I didn't mention. Cosecant has symmetry with respect to origin. Look, if you take a value here, reflect it against origin, you hit another value. Take this number, reflect with respect to origin, you have this. Take this number, meet origin and go the same distance, you have this. So cosecant is symmetric with respect to origin. However, secant is with respect to only y-axis. It has y-axis symmetry. Okay? So these are worth mentioning. What we are going to do is we are going to make picture of cosecant. By the way, this is not the final picture. This is the picture of only cosecant. We are going to change this, transform this picture according to x over 3 inside. It's not just x, and 3 outside. Okay? So I will first start inside. This is the tricky one. We know what outside 3 does. What does really 3 does outside? Anyone? Multiplying a function by a big number. What kind of change do you expect in the picture? It's going to stretch things. Every number will be 3 times bigger. Instead of, for example, pi over 2 to 1, it's going to move to pi over 3 to 3. This point, for example, is going to move up. This point is going to move 3 times more. It's going to move to 6. This is sitting at 2. It's going to move to 6. This will be moved to 6. So everything will move up, stretch up actually, not just moving up. Alright, that's easy. That's second part. I can do stretch always later. Important part is what kind of change x over 3 makes. And I always recommend doing this with inequalities. So in regular terms, cosecant has one period of frame from minus pi to pi. So first put it down. X's are in regular cosecant is between minus pi and pi. Look, I take this picture in the middle. It's between minus pi over pi. But this, we don't have just x. It's x over 3. So put this entire inside right between these two. Remember, in the previous section, when we are sketching sine and cosine, we were putting whatever you have inside between 0 and 2 pi, because the period of sine and cosine was from original sample period was from 0 to 2 pi, but the sample period for cosecant is from minus pi to pi. For secant, sample period is from minus pi over 2 to 3 pi over 2. I'm going to set x between minus pi over 2 and 3 pi over 2. Alright, so we start off with this, and I need to solve for x. I need to get rid of 3. So what can I do?
Multiply by 3.
Yep, we will put 3 to all 3 sides and multiply. And we will have these two cancelling out. And the final result is that. So that means this picture right in the center, this frame, ignore the rest, is going to spread into minus 3 pi to 3 pi. This picture, this U shape is going to spread into, it's going to span a range of minus 3 pi to pi. So we have a bigger period. Used to be 2 pi, now it's 6 pi because you got 3 pi left, 3 pi right. Total you are spreading into 6 pi period. Okay? So I'm going to make a brand new sketch now. And in ordinary terms, it was supposed to be from minus pi to pi. This is minus pi to pi. I'm going to make this now 2 pi, 3 pi. And that one will be negative 2 pi, negative 3 pi. And put those two vertical asymptotes right on those. Vertical asymptote here, vertical asymptote there. And there is a vertical asymptote in the middle. Still, the middle asymptote is right between minus 3 pi and 3 pi, so it's still sitting at 0. So the only thing doesn't change in this frame is the center asymptote still at 0. But the others moved into 3 pi and pi, negative 3 pi and positive 3 pi. Okay? All you need to do is now make these blue pictures, U shapes, now in a wider area, 3 times wider. Alright, so I'm going to go with this option and make I'm not a good sketcher, so I need to mark the middle value, and same thing here. Alright, question. In the previous case, original cosecant, those middle values were at minus pi over 2 and at pi over 2. These two minimum and maximum value. Maximum and minimum value were at pi over 2. Now who can tell me the new locations of those? Where do you think it is? Yeah, it should be between 0 and 3 pi, right in the middle. So add 0 and 3 pi, take half, it is 3 pi over 2. And this thing is going to be right between these two. It's negative 3 pi over 2. Okay? Alright. Our question is over. You can keep repeating same pictures to the right and left if you wish, but one period frame is enough. Okay? Oh, are we done? No, this is incomplete. So this is only first step. Right? We have also stretching part. We didn't do this. Sorry, I missed that. So you need to stretch this up into 3 units. So if this is 1, it's going to move really right here and go up. So I will already do it on the picture. I will mark this 3, kind of cheat. Minus 3 and 3. There you go, it already moved up. Originally again, it goes like this. 1. So this is the original picture. I stretched this up and this stretched down. Instead of going from 1, it's moved up 3. Okay? I just did it on the picture. But your job is easier in the question because it's a multiple choice question. Just because it's multiple choice doesn't mean you're gonna cheat, go from the options. No, always make a picture on the white page paper and then go pick the right option that's most similar to yours. Again, alright, it looks like they picked a frame from 0 to 6 pi on this one, 0 to 6 pi, 0 to 6 pi. So they made the picture from 0 to 6 pi. So you need to consider the part from 0 to 6 pi part here. I don't have 0 to 6 pi, but so they have considered this range, 0 to 6 pi. So that you know this is just gonna move here if it's 0 to 6 pi, okay? Because this keeps repeating. So when you see this 0 to 6 pi, this is the vertical asymptote. 0, 3 pi, 6 pi will have vertical asymptotes. And the minimum value will be at 3. Maximum value here will be at -3. I have a feeling it's part D, right? No? What's wrong? Which one? Yeah. The correct picture is B. I need to start with a regular U shape and upside down. What is wrong with part D? This is upside down and then U shape. Again, mark these values. Do we have 3 pi? No, where was B? Do we have this minimum value at 3 pi over 2 and 3 in our picture? Yes, 3 pi over 2 and 3. This is 6 pi. No, between 3 pi and 6 pi is, yeah, 9 pi over 2, 3. This is 9 pi over 2, 3. How did I get it? I just added 3 pi and the next asymptote 6 pi and divided by 2 to get the mid value. Alright? Alright, that seems like B, the right answer. Alright, they didn't ask the period, but again, in case they do, the period is, what is the period? What's the new period? Period is always found by B over, no, it's 2 pi over, old period over B. B is the number in front of X, which is 1 over 3. And I flip and multiply, it's 6 pi. Okay? Alright? Or in other words, you pretty much measure the distance between these two. It's 6 pi. How do I know this period calculation again? It's from this. 2 pi over B is the period of sine and cosine. It's the same thing for secant and cosecant as well. Amplitude is the number in front, which is 3. Phase shift, we don't have any C in the question, so there is no phase shift. 0 phase shift. We didn't shift anything. Again, I'm using this fact. I'm not writing this again. This fact from the previous class to get the amplitude, phase shift, period, etc. Alright, we are going to make another question now, but this has more numbers. It has a number in front of X, it has a number after X, and then all the way at the very end it has a number. So I copied the picture of secant. This is where you start. I will pick one time period, or I'm sorry, period frame. I will pick minus pi over 2 to 3 pi over 2. And we are going to shift it according to these numbers. Okay? So I'm going to do it in the next slide. So what's the time frame we picked? It's between minus pi over 2 and 3 pi over 2. Here is minus pi over 2. Pi over 2 and 3 pi over 2. This is pi over 2, pi, 3 pi over 2. We have initially two shapes here. This and that, am I right? This and that, yes. Alright, this is secant. This is secant. What we need to do is, first off, we need to compute cosine minus x. Wait a second, I don't like minuses. Do you remember? The last question we did on the previous section was related to this topic. When you had a minus in front of an x, we need to take care of it. Okay? So, is there a way you can get rid of a minus in front of this object in this equation? I know that for cosine minus x is the same as cosine x. For sine minus x is the same as sine x. Is that right? I can just wipe off like that. Is that correct? Am I right? No, this is incorrect. We move the minus out front. What is this property called? It's evenness and oddness of sine and cosine functions. Where have we seen it? There was a table for it. It was in 5.4, I believe, right here. Even and odd properties of sine and cosine. Sine negative can be negative of sine. Cosine negative angle is just cosine of positive angle. However, what's interesting for us currently is secant. What does secant do to negative numbers inside? Well, I see that when you have a negative number, we not only move it out, we just wipe it off. You can just lose the minus sign because it's equal to sine, secant. It acts like just cosine because secant is actually 1 over cosine. Okay? Alright, that's good to know. So that means I can factor out the minus and get it out of my way from our equation. So this equation is the same as, just call a minus out first. And by evenness property, we can wipe off this thing by evenness. But if there are two terms again, you need to factor a minus from each of them. Not only x, but also pi over 4. So this is going to be the same as secant x plus pi over 4 and minus 5. Okay? Make sense? So they kinda tried to trick us with negatives, but we got rid of the negatives, and this is what you need to plot now. Alright. I'm going to first make a shift of pi over 4. How? I will just start from scratch and do this. Regularly, this was minus pi over 2. This is 3 pi over 2. This is pi over 2. One period frame x is between minus pi over 2 and 3 pi over 2, right? But here in our question, we don't have just x, it's x plus pi over 4. So all I'm going to do is subtract pi over 4 from all three sides. Please do so and tell me the result. What is minus pi over 2 and pi over 4? Set the common denominators and do that. it is minus what? 3 pi over 4. So this moved pi over 4 left, more left. Middle is just x now, and the right side is, here you set the common denominators, multiply this one by 2, both top and bottom. 6 pi over 4, take away pi over 4 is 5 pi over 4. So this end went pi over 4 left. Everything moved pi over 4 left. So I'm going to shift these asymptotes first, pi over 4 left, and this one too. Even the middle point will move pi over 4 left. No, a little right. It should be between these two lines, and this one will move here. Okay? And guess what? This guy is going to move between the green lines now. There you go. And this one is gonna move between the green lines. Everybody is moving pi over 4 left. Are you with me? Again, let's mark important values, significant values. This point is -3/4, -3 pi over 4. This point is, oh, I didn't compute this, but when I take it off, pi over 4 from 90 minus 45 is 45, so it's another pi over 4 here. This is pi over 4, and this is 5 pi over 4. Agree? Yeah. Start, end, and mid value. Alright, I'm wondering what this number is. What this value is. Anyone? How would you get it? Any ideas? Perfect. It's between these two green lines, right in the middle. So just take average of 3 pi over 4. So add them, 3 pi over 4, add pi over 4. And average means divide by 2. When I add these two, minus 2 pi over 4. But these two will cancel. So it is minus pi over 4. Okay? Or doesn't this make sense? This point is between this blue line and y-axis. Blue and y. It's right in the middle. This is 90. This is 0. Between should be 45 or pi over 4. So you can do it by logically, by the appearance. But the real math is here. Okay? So this was the transformation pi over 4, left shift, left pi over 4. What kind of shift does this make? Anyone? Yep. So all you need to do is next, please move this 5 down. Okay, what is the original location of this guy? What is this value? I'm wondering this, and that one. What is the original minimum and maximum values here? It's both 1 and -1, right? So when you shift all these 5 down, this is going to be -4 and -6. So can you imagine that? So I will move this guy 5 down. 0, 1, 2, 3, 4. This is gonna move there. And this is gonna be two lower, -6. Alright? This is -6. This is -4. To be more particular, this point is -π/4, -4. This is oh, we didn't compute it, but what is this value? Average is 6π/4, 3π/4. 5π plus pi makes 6π/4. Take half, 3π/4. Okay, so I sketch one frame. If I need more frames, I will just copy this, each U upside down U shape, right and left, according to what is asked, what range is asked here. Alright, they want us to pick the right choice from 0 to 2π. No. Yeah, on the positive x-axis, but not necessarily 0 to 2π. This is 0 to 2π. This is 0 to 7π/4. So which one is the right choice? They want to do so I make sure we are solving the same thing. Yeah, it's the same thing. So which one is the right option? It's not this one, because asymptote is not pi. Is it this one? Pi, it's going towards pi. This has asymptote pi. My asymptote at π/4 is it this one? No, this has no asymptote at, no, this has asymptote at π/4, but it's too high. We don't have something here. We need to go lower. I wish this was down somewhere like this, right? Is it correct? Look, this piece is here, and where is that upside down cup? Here at 3π/4 -6. Yep, 3π/4 -6. And there is a right piece. If I make this move here, there is going to be a right piece here from π/4 to wherever this final location is. So yeah, it seems like this is the right option, right? Am I right? Do you all agree? Because it looks like mine is not extending all the way up, but no, this guy will go up quickly. It's gonna go very parallel to this. Alright? So it's gonna make a shape like this. 3π/2 here. Just like this guy. And I see it's -4. The minimum values are -4. This is -4. Alright, I'm gonna go with D. Alright, that's right. Any questions so far? Alright, two more graphs. Tangent and cotangent. We'll do one example of each and we'll be done. So, graph of tangent. By the way, what is the period of tangent? Same picture frame keeps repeating over and over. What time period it happens? Is it 0 to 2? Is it 2π again? No, this time tangent and cotangent, those two only out of 6, they have shorter frequency. They do the same shape more often. So it's pi only. Look, minus pi over 2 to pi. So this is one frame. One picture keeps repeating more often. Minus pi over 2 pi, pi over 2 to 3 pi over 2. The distance is always pi. At every pi range, the shape repeats. So sine, cosine, secant, cosecant, all are wider periods, 0 to pi extension, but tangent and cotangent have half the distance. They go half the distance and complete the term. And tangent is always going all the way from down to up. From left to right, it's increasing. Left to right is increasing, going up, going up, going up. And at every odd multiple, at every multiple of pi over 2, you have an asymptote. Pi over 2, pi. 3 pi over 2, 2 pi. 5 pi over 2, 3 pi. 7 pi over 2, 4 pi. At every 90-degree distance, pi over 2 distance, you have an asymptote. Same thing for cotangent. Cotangent is just reflection. You flip this shape along its center, like y-axis, flip this right and left, you get, no, it's not only flip, it's also shift. You flip and shift it to pi over to the right, you get cotangent. It's going down picture all the time, but the center is shifted from, instead of y-axis, to pi over 2. So at every pi range, again, 0 to pi, pi to 2 pi, same shape repeated over and over. Again, let's mention what I said on the picture in the table. So domain of, tangent and cotangent doesn't work with all angles. Tangent doesn't work with odd multiples of pi over 2, like pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2. Tangent fails. You cannot measure these values. So we need to exclude these values from the domain. Or in other words, you have vertical asymptotes there. When for tangent, odd multiples of pi over 2. For cotangent, just multiples of pi. 0 pi, 1 pi, 2 pi, 3 pi, you have a problem there. Tangent has symmetry at origin. Cotangent has also symmetry at origin. Both are symmetric with respect to origin. We call them odd functions. So when you have a negative number inside a cotangent or tangent, you can pull it out in front. Okay? Period is shorter, both. And that's pretty much it. Alright? So I don't want you to memorize these, but just keep in mind this little frame, this picture, keep this in mind. You can get every detail on this table from these pictures. Look, it's going up through 0, minus pi over 2, pi over 2. We have a problem. Keep repeating and repeating. You have all these properties speaking up on this picture. Okay? Alright, let's make a picture of tangent with some changes. First off, I know what 1 over 3 is going to make. It's going to shrink it. It's going to bring the picture down towards x-axis. Pi over x, I'm wondering what kind of change pi over x makes. So just take one frame. One frame of tangent is minus pi over 2 to pi to here. And now we will shift it. So the original picture is this guy. This is original frame. Okay, and original numbers are minus pi over 2 to pi over 2. So we have x values are between these two. But now what's the difference? We have a pi given in the question. I'm wondering where these start and end values will move. Alright, all you need to do is we need to get rid of this pi. So how do I get rid of the pi in front of x? What operation do we do on all three sides? Divide by pi. Divide by pi, divide by pi, divide by pi. So we have all these gone. So we have minus 1 over 2 on the left. And this is positive 1 over 2. Okay, now please answer this. With these new start and end values, this is start, this is end. Where do you think these blue lines are going to move? Is it going to move inside direction, or are they going to move outside direction? Where is minus 1 over 2 and 1 over 2? Is it between these two or after these two? Between. How do I know? Because pi over 2, pi is 314. Pi over 2 is about 157. This value is 157. Where do we move it? To 1 over 2. So 1 over 2 is a lot shorter than this. This is 0.5. This is 1.52. It's about 1/3. So you're moving this guy to this and that short span. This one. Do you see that? Alright. This is gonna be a narrow picture. Okay? So I'm gonna narrow it down here. Or instead, why don't we start off with a wide picture and then narrow it? I'm gonna move these numbers to the right. Yeah, much better. And this is now gonna be about 1/3 of this distance. This is 1/3 of it. Seems like 1/3 of it. Now we are gonna make new picture of tangent, or that shape right here. Again, what are these values, new values here? This is minus 1 over 2. That's 1 over 2. Instead of 1.5, you are at 0.5. 1/3 the distance. Okay? What else is left? We're gonna shrink this. So, for example, let's take a sample value. This sample value. Measure this unit. Whatever this is, eyeball it. It's going to drop to 1/3. This means 1/3. This height, this tall guy is gonna drop to 1/3 the distance. So it's gonna drop here. This one. And this one, for example, is gonna drop to 1/3 here. 0, however, 0 is not gonna move because 1/3 of 0 is still 0. Alright, how about this? This distance, this height or depth is going to drop to 1/3 again to here. This one is gonna drop to here. Do you see the shrinkage? Long tense rope turned into a loose shrinked piece of string. Of course this is gonna extend out that way, that way. So we are gonna look for this shape between minus 1 over 2 and 1 over 2 in the answers. Okay? Alright, I have a couple questions. What is the amplitude? I believe we are going to answer that in the homework. Amplitude is, what's that?
None.
None. Yes. Tangent doesn't have any amplitude. It's infinity, going to infinity. Okay. So even it's shorter, 1/1/3, it's still none. Okay. How about the period? It's 1. Kind of add these two numbers, or subtract these numbers. 1/2 minus 1/2. You subtract those two numbers and see how much it extends out. So from here to here, you measure it. 1/2 to the left, 1/2 to the right. Total is 1. This thing is 1. Because 1/2 plus 1/2 is 1. So period is 1. What is the old period? Old period was pi. Now it shrunk to 1. I don't know what else is asked, but let's check out. Alright, over the domain -1, the function has, it's asking for x-intercept between -1/2 and 1/2. Can you spot an x-intercept? What is the x-intercept of this purple or this final result? What is the x-intercept? I think they're asking this value. This is x-intercept, right? And what is it? How do you find it for other shapes? You always average these two numbers, okay? If this was somewhere else, for example, it would be half of the sum of these numbers, okay? Whatever they were. But here it's 0, obviously. Oh, we have a problem. Oh, good point. Thanks, Ashley. So it has to be 2 coordinates. Alright, the points blah blah and blah blah are midway between x-intercept found in part A and the asymptotes. Alright, it just says between asymptotes and x-intercepts find 2 points. So what is the first point between asymptote and the intercept? They're asking this value. Find this. And they're asking this value because it's between x-intercept and asymptote. X-intercept and asymptote. Find that one as well. So what do you think those values are? 1/4. You average 0 and 1/2. It's 1/4. Quarter. Half of a quarter, right? So it's -1/4 on the left. Zero, of course. Oh, hold on. Is it 0? The points are midway between x-intercept. So they want not x value of it. They want when this curve crosses my tangent curve, it makes this contact value. They want its x and y coordinates. X coordinate is 1/4, but what is the y coordinate? How do I find it? Enter -1/4 to tangent and find it out. Okay, so I'm gonna do that here. So they're asking for 1/3 of pi times -1/4, and on the other side +1/4. Well, isn't this tangent 45? What is tangent 45? Tangent pi/4. Sine over cosine. Sine and cosine equal each other there. So it is 1, yes. So this is 1/3. How about tangent -1? Oh, by the way, if you have a negative sign in a tangent, you can pull it out so it matches to pi/4. So these two values match, but you have an extra minus, so it's -1/3. -1/3 and +1/4. This one will be 1/4. Right? Looks good? Alright, now we're going to the graph picking area. We need to pick the right option that looks most similar to ours. Ours is going -1/2, 1/2 rising picture. Okay, which one? This is decreasing. Nope. Decreasing, rising. But it should be between 0 and -1/2. Yeah, 0 and 1/2, -1/2. It looks like this one, right? And the points are already sketched correctly. Let's be going with part 4. Alright, the other half of the question is about another graph. So you need to restart the question, make this picture, and do the other similar parts. I'm not gonna do that, okay? So I am leaving this part to you. Very similar, except instead of a shrinkage, your picture is going to stretch, and with this minus sign, you're gonna reflect it across x-axis. So this is gonna be a decreasing, stretched, but pi x, you see the same pi x. Same pi x. So same period, 1/2 and -1/2 and 1/2, but it's upside down and stretched rather than shrinkage. Okay? So this is enough about tangent, one part. I'm gonna go to the cotangent, and we're gonna make a picture of cotangent next. It was only one part. You need to make the picture and pick the choice. Which I didn't copy, I believe. We can just copy that question here. It is f of x y equals 2 cotangent 2 pi x minus pi/2 plus 2. Alright, this is stretch, this is up. I know these are easy. Stretch, stretch. They're no big deals. What concerns me is inside. I will first make the inside, okay? Let's compute inside first. What is the regular period of cotangent? Let's pick a frame. You can pick this left side, this one, but I will pick this one because I like working with on the positive side. I will pick this one and take and transform this shape 0 to pi. So I will take x values from 0 to pi. Regular x values are from 0 to pi, but this one has some numbers next around x, so we need to first clear them. I will add pi/2 first. I see there is some right shift going on here. This makes 3 pi/2. Add the denominators, set the common denominators, etc. pi/2. By the way, I keep putting these equal signs here, but technically your axis can never hit those asymptote values because they are undefined. We shouldn't be using it. There is no real harm. And then I will divide both sides by 2 pi. 2 pi, 2 pi. And these pi's will cancel. And this dividing by extra 2, you already divide each term by 2. Dividing by extra 2, it's gonna make a quarter. So this 1/2, half of it, 1/2 is gonna make 1/4. And this is gonna make 3/4. Okay, I have a feeling what's going on here now. So we have a shorter period, 1/4 and 3 pi/4. What's the distance between them? Only 1/2 or 2/4, 1/2. So you have a period of 1/2, but so we are narrowing down the picture. I'll try to fit it in here. So the regular region was between 0, so these are two asymptotes, 0 and pi over 2, the regular one, right? This is pi over 2. What is the new range now? It's not 0 and pi over 2. It's gonna move to one over 4 and 3/4. Well, I need to know approximately how much pi over 2 is. What is the decimal value of pi over 2? 1.57, right? So I need to move to 0.25. Wow, that's really small. And 0.75. This is 0.75. So 157. Comparing 157 to 0.75, I need to go less than about half of it. Yeah, it's right, almost half the distance. 75 is almost half of 150 almost, right? So I will go half the distance now. This is where the right end goes. About the left end, 0.25 is about 1/3 of this distance. 1/3 of this distance, so I will go, yeah, almost a little bit to the right. Good. So what are these two locations now? 1/4, 3/4, 3/4. Just fit in your cotangent here. That function right here. Is it this way? Is it? No, cotangent is upside down, right? Not this one. This is tangent. We need to go this. Or please tell me what this middle value will be. What's between 0.25 and 0.75? Yes, 1/2 or 0.5. Or add these two and average them. Average, divide by 2. Okay. This part done. We still have to stretch it twice and move up 2. So I'm going to stretch it now twice. Looks good. Every point goes twice the distance, twice the height before. All y values are doubled. So this is twice the cotangent. Twice cotangent of whatever this mass was. Now what is next? I will move it up. Move this thing up 2 units. So this is a good reference point. I'm gonna move it up to 2, and it's gonna be really up there. And this point will be now 1 over 2 comma 2. Okay, and let's make the final picture here. Got it? And this is 2 up. Alright, let's pick the right choice. Oh, and imagine you have a copy of this everywhere. Copy this thing. Everywhere, alright? Every same distance though, not but this wide. Pi over 4, 3 pi over 4. And we add another 1 and a quarters, for example, is the next visit. Alright, so let's see which one is right. This is a rising graph. No. Needs to be going down, right? Decreasing. This is up. This looks like a good one. It's either part C or D. Which one? It looks similar, but this is moved down. You see this in the negative value. It seems like this is the right option. 2 comma 1 over 2. 1 over 2 comma 2. I'll repeat it everywhere, so it's C. Again, don't go with trial and error. Do it on paper. So let me just mark C here. I need you to be able to do this on paper, okay? Alright? Alright, this is all for today. On Monday, we are going to take a look at inverse functions.